Good day. In this video, I'm going to discuss one of subtopic of partial differential equation, which is the D'Alembert solution to the wave equations. To define, D'Alembert solution is a solution to wave equation in an infinite one-dimensional domain. In other words, x varies from negative infinity to positive infinity. Since we have an infinite domain, there will be no sorry, there will be no explicit boundary condition. However, we have two initial conditions to consider. And these are, the first condition is u of x0 is equal to u sub 0 of x, and this is called some initial displacement. The second condition is partial derivative of u in respect to t at time 0 is equal to v sub 0 of x, and this is called some initial velocity. And for this lecture, we will solve PDE's problem and find the solution for infinite spatial domain with the use of these two conditions. To begin, we are given a general solution to wave equation, which is u of x t is equal to the summation of function f of x plus ct plus g of x minus ct. To elaborate more the meaning of this formula, we suppose f of 0 is a fixed point, fixed x plus ct is equal to 0, then x is equal to negative ct. So we can see by this that these equations are moving backwards. So we call this equation as backward traveling wave. And this equation, suppose g of 0 is a fixed point, fixed x minus ct is equal to 0, then x is equal to ct. So we can see, or we can say that this is moving forward. So this function will be forward traveling wave. Going back to the topic, by this equation or by this general equation, we don't know the value of f and g. So we need to find or solve for it. To find the unknown f and g, we need to substitute the initial conditions to general formula. First, substituting the first initial condition, at t is equal to 0, u of x 0 is equal to u sub 0 x is equal to f of x plus c times 0, which we substitute t into 0, plus g of x minus c times 0. So we will be coming up or come up with this formula, the u sub 0 x equal to f of x plus g of x. And we label this as equation 1. Next, substituting the second initial condition, the first we need to find the partial derivatives of u in respect to t. And this is equivalent to f prime of x plus c or x plus ct multiplied by the derivative of this function, which is the c plus g prime of x minus ct, and and multiply it by the derivative of x minus ct, which is negative c. At t is equal to 0, partial derivative of u in respect to t at time 0 is equal to v sub 0 x is equal to c times f prime of x plus c times 0 minus c times g prime of x minus c times 0. And we will be coming up with this formula as v sub 0 x is equal to c f prime of x minus c g prime of x. And we label it as equation 2. Next step is integrating the second equation from x sub 0 to x. When integrating the second equation, the prime function will becomes its antiderivative function or its antiderivative. So we will be coming up with this formula. The integral of v sub 0 s ds evaluated from x sub 0 to x is equal to c times f of x minus f of x sub 0 minus c times g of x minus g of x sub 0. To simplify this formula, we need to move all the constant at the left. So 1 over c times the integral of v sub 0 s ds evaluated from x sub 0 to x plus f of x sub 0 minus g of x sub 0 is equal to f of x minus g of x. And this will become our third equation. Equation 1 and 3 are both in terms of a known value of f of x and g of x. So we will going to solve the system of equation. This is the equation 1 and this is the equation 3. First part is adding the two equation. So we will be having a u sub 0 of x plus 1 over c times the integral of v sub 0 s ds evaluated from x sub 0 to x plus f of x sub 0 plus g of x sub 0 is equal to f of x plus g of x plus f of x minus g of x. The g of x will be cancelled and the 2 of x and the f of x will be added, so it will become 2 of f of x. To simplify this equation, we divide it by 2 and replace x by x plus ct. So if we divide it by 2, the 2 of f of x will be cancelled, and the remaining will be f of x plus ct is equal to 1 half of u sub 0 x plus ct plus 1 over 2c times the integral of v sub 0 s ds evaluated from x sub 0 to x plus ct plus f of x sub 0 plus g of x plus sub 0 over 2. This will be our function. The next part will be subtracting the two equations. And we will be having a u sub 0 of x minus 1 over c times the integral of v sub 0 s ds evaluated from x sub 0 to x minus f of x sub 0 plus g of x sub 0 is equal to f of x plus g of x minus f of x plus g of x. The f of x will be cancelled and the g of x will be added. It will become 2 of g of x. To simplify the equation, we divide it by 2 and replace x by x plus or x minus. It is minus, sorry. Minus CP. Minus CP, sorry. So the remaining formula will be g of x minus ct is equals to 1 half u sub 0 x minus ct minus 1 over 2c times the integral of v sub 0 s ds evaluated from x sub 0 to x minus ct plus g of x sub 0 minus f of x sub 0 over 2. And this will be our function g of x or g of x minus ct. The next step will be substitute the f of x plus ct and g of x minus ct to the general formula. And we will be coming up with this equation. As you can see, this function will be cancelled out by this function. And we are switching these limits. And when we're switching these limits, the negative 1 comes out. So it will be going to positive, this function will be going to positive. So the remaining function will be 1 half u sub 0 of x plus ct plus 1 half u sub 0 of x minus ct plus 1 over 2c times the integral of v sub 0 s ds evaluated from x sub 0 to x plus ct plus 1 over 2c times the integral of v sub 0 s ds evaluated from x minus ct to x sub 0. And there are properties that we will be combining these two integral, which is the integral of a to b plus b to c is equal to the integral of of a to c. So after we simplify this equation, we will be coming up to our final formula, which is u of x t is equals to 1 half of u sub 0 x plus ct plus u sub 0 x minus ct plus 1 over 2c times the integral of v sub 0 s ds evaluated from x minus ct to x plus ct. But in the book, or in this equation, the u sub 0 is equal to our f and the v sub 0 is equal to our g. So to substitute or to change, this equation will be u of x sub t, or u x t is equal to 1 half of f of x plus ct plus f of x minus ct plus 1 over 2c times the integral of g of s ds evaluated from x minus ct to x plus ct. And these equations are what we call the D'Alembert's solution of the wave equation.
And now, we will be going to solve some problems using the D'Alembert solution of wave equation. For example number 1, the first thing we do is to list the given. C squared is equal to 1. How do we get this 1? In this function, this variable has a coefficient of c squared, which is 1. So c is equal to 1. For the function of x, this function is our f of x, and this function is our g of x. So, our f of x is equal to x, and g of x is equal to 1. Now, using the D'Alembert's formula, which is 1 half of fx plus ct plus f of x minus ct plus 1 half of the integral of g of s ds evaluated from, I forgot the c, x minus ct x plus ct. To substitute the given, the f of x is x, and since c is 1, we will be left by t. So, plus x minus t plus 1 half, since c is 1 again, multiply by the integral of 1 ds evaluated from x minus t to x plus t. To simplify the equation, 1 half, the t will be cancelled out, so we will be left by 2 of x, or 2x plus 1 half of the integral of 1, which is s, evaluated from x minus t to x plus t, equals to cancel out the 2, and we will be left by x plus 1 half of x plus t minus x minus t. But first, I will be rewriting the recent equation, which is x plus 1 half of x plus t minus x minus t. To simplify again, x will be cancelled out, so we will be left by x plus 1 half of 2t. And 2 will be cancelled out again, so our u of x t is just x plus t. Since we need to find the value of u of 2, 1, so our u2 of 1 is equal to, we just need to substitute it, so 2 plus 1, this number 2 will be our x value, and 1 is our t value. So our u2, 1 is equal to 3. That is the final answer. And for the next example, our given is c squared is equal to 4 because of this coefficient 4. So our c is equals to 2. Our function of x is equals to that function, negative x, and g of x is equal to that function, cos x. Again, using the D'Alembert's formula, u of x t is equals to 1 half of f of x plus ct plus f of x minus ct plus 1 to c times the integral of g of s ds evaluated from x minus ct to x plus ct. To substitute the given, 1 half of our f of x is negative x plus our c is 2t. Substitute again the f of x, which is negative x minus 2t plus 1 of 4, since c is 2 times the integral of cos s ds evaluated from x minus 2t to x plus 2t. To simplify the equation, 1 half of 2t will be cancelled, so we will be left by negative 2x plus 1/4. The integral of cos s is sine s evaluated from x minus 2t to x plus 2t. To simplify, 2 will be cancelled out, so we will be left by negative x plus 1/4 of sine x plus 2t minus sine of x minus 2t. Again, rewriting this formula, which is negative x plus 1/4 times sine of x plus 2t minus sine of x minus 2t. According to the property of subtracting two sine equation, sine A minus sine B is equal to 2 sine A minus B over 2 cos A plus B over 2. And substitute this formula, negative x plus 1/4 of 2 sine of A minus B over 2 cos A plus B over 2. Simplify it. Negative x plus 1/4 2 sine this function is A. So substitute it, and this function is B. X plus 2t minus x minus 2t all over 2 cos x plus 2t plus x minus 2t all over 2. Cancel the 2t and x equals to negative x plus factor out the 2, which will becomes 1/2 of sine 4t over 2 cos 2x over 2. Divide the 4 over 2, which will be given as 2, and cancel the 2. So u of xt is equal to negative x plus 1/2 of sine 2t cos x. This is the final answer. And this is the end of my topic, the Alambert's solution of the wave equation. Thank you.